All right. So the last technical talk, I think before lunch. Today basically is a milestone in our journey of understanding the Yilgarn Craton and its margins, and I'll make some comments on what we've seen today. I'll start with a summary. So basically, some of the main findings, and by no means a complete list, right? Because we've seen a lot of data this morning, different kinds of data sets. The structure along the dying fault vary considerably in age and kinematics. We've seen that from Ivan's talk and from what Charmaine has presented before. We also see substantial differences between Archean crustal domains. We have seen that before in the mapping and the potential field data. We have this more kind of dome and keel type, almost East Pilbara looking domains in the west Yilgarn Yalgoo. But showing the seismic lines going through actually shows that the seismic structure varies really accordingly, also at depth. So these are really different types of Archean crustal domains. We have the lack of the crustal reflectivity zone in the Yalgoo area. We have a more kind of lozenge style you and me terrain that Tim, Raf, and Ivan talked about. And we have in the southwest one line, the crustal shortening during the Corrigan tectonic zone event, and a thick crustal root. That's something that we have never seen before in Archean crust in WA. So usually, and this has been mentioned before, we had a sharp moho, and overall a lower crustal fabric that's often highly reflective and has a strong eastward dipping component. As the discussion with Graham earlier Graham pointed out, it's not really an east dipping fabric, it's an east dipping component of the fabric, because it also has in some areas a south dipping component as well. So but what I'm going to talk about a little bit is along strike variations in the northwest structure bounded domains, including in the Perth basement, and difference in Archean domains, and we'll highlight some future works. So basically, what is it as a survey we can contribute, for instance, to understanding of mineral systems and things like that? Well, the thing that we are good at is large-scale imaging, acquisition, processing, and interpreting large-scale lithospheric scale data sets. So, in terms of the whole understanding of mineral systems, what we want to know is what's happening at the margins of crustal blocks. How do the crustal blocks form? Cratons form. How they get modified? So, as an example, these are the from GeoView, the gold resource estimates relative to the major crustal boundaries that we've published a few years ago. And the major crustal boundary layer, I can only recommend that. It's on GeoView. It's also got a report to it, and it's a 3D model to it. So it's actually our understanding at like 3 or so years ago. But mainly in the Yilgarn Craton, of course, the traditional subdivision is along those north to northwest striking structures, and you can see that not all of them line up necessarily with the gold domains. Interestingly, the only one that lines up really sharply is the Yilgarn shear zone along the Southern Cross area, and here, whereas in the Kalgoorlie area, it's more dispersed, more widely spaced, but of course richer. So lithospheric structures, of course, are traditionally seen as pathways for magma and fluids. And so we've pointed out the lozenge structures before. One of the intriguing things in the Yilgarn Craton, a very, very symmetrical or seemingly symmetrical fabric that has components like this, but it also has a lot of components like this. And as we've seen before, the long axis of these lozenges is basically north-south. And that is something we'll come back to. And again, in this map that Ivan and Raf and Tim have worked on, have put together, you can see the tightening of those lozenge structures in the corrogen tectonic zone quite well, but also it's more tight in the eastern goldfields. Look like symmetrical at the surface, but as we've seen before, in many of those seismic lines, and we haven't actually talked about this one, this is the Yom line, shows the same thing. Yilgarn Officer Musgrave, we have a strong eastward dipping fabric. So where you can map the surface fabrics into the crust, only one set of those, and we haven't systematically done that, but in most cases, it's the one that are more northeast oriented. They are the ones that go all the way down or go deep into the crust. Some of the other ones are kind of constrained to the upper crust. So it's not really, the two components are not equivalent fabrics that go all the way down into the crust. That's really important, I think, to understand. So it's been really, this was the most baffling thing, I think, when I kind of started 13 years ago or so, interpreting the YU lines, having that symmetrical fabric from the potential field and the outcrop mapping, and then seeing the asymmetry of it. Really, really interesting. Okay, another thing that that Raf has pointed out before, very, very strong, very sharp moho. Some of the defining features of most of the Yilgarn Craton. There is a step in the moho as we go across the Darling Fault, across the Ida Fault into the Eastern Goldfield, steps down a little bit, and it's a bit thicker there. But overall, very, very sharp and defined. And of course, we have that bulge, and we have that CTZ event that seems to stack and create an orogenic belt that is quite rare globally in Archean cratons. There's not many examples. There might be some. There might be some in Southern Africa, but this would be a big surprise to us. We wouldn't have expected that. Okay, some of you might be familiar with the east-northeast trends that we've worked on a while ago, coming from geochemical data sets. Basically starts with Hugh getting his fingers hurt by sampling granites in the field, as shown here. And then, so we have an amazing data set of, I think, nearly 10,000 felsic igneous geochemical samples that allow us now to really map the distribution of igneous rocks. And so this east-northeast trend is a bit of a problem if you are a firm believer in accretionary tectonics, because it seems to be cutting across large-scale structures that some people think are first-order plate boundary type structures. And so, as Huayu will talk to you in the afternoon, some of these trends, they come up again, also in the crustal thickness, the moho depth today, and also in the compositional averages that you can calculate for as a VPVS ratio, the Poisson ratio of pressure wave and shear wave velocities. So these are interesting fabrics. They're only really consistent in the south, which is interesting in itself. So how in a more detailed view, I've chosen three lines through the velocity model it's the receiver functions and the H kappa moho. And if you look at the one in the Perth Basin, as Charmaine has pointed out, it's very chopped up from north to south, so very, very segmented along strike, as you would expect from what's been shown in the depot centers and the depths to basement. But very interesting, and this is certainly something we'll keep working on, trying to marry those different kind of seismic structures or domains against the basin and sub-basins in the area. If you go, move into the you and me, and there you can see something interesting. It's kind of in the northern you and me domain, you have a kind of a less defined moho. So this is a receiver function, so it gives you the velocity contrast in the crust where P and S wave different waves convert at material boundaries. So it's a very sharply defined central you and me moho. But then as you approach, and this thing here, CMRA, is the Creton margin, basically going into the Albany Fraser here. But you see, all of the southern part of the UNME terrain is this correlates very well with that high strontium over yttrium zone. So it's a different type of seismic structure along the southern margin of the Yilgarn. Within the Eastern Goldfields and the Kalgoorlie terrain, we also have a very, very sharply defined moho and very, very subtle changes at that scale. But actually, you can see that there are changes and steps in the moho and in the kind of seismic structure of the crust. So there are along strike changes. If you want to resolve that, if you want to look at this in a higher resolution, there's a poster over there, a paper by Andy Calvert that has just been published on last Friday, that shows the along strike variations in the Kalgoorlie area itself. So yeah, clearly we get really interesting changes along strike. So it's just a plug for that paper, but yeah, just have a look at the poster. And so, yeah, what is it we are looking at here? And one of the possibilities that we've been discussing is that we have these east-northeast trend, and this is very simplified, right? In detail, they are much more subtle. They're not always parallel and so forth. But these east-northeast trends, they represent long wavelength compositional variations. They're not really sharply defined structures. What can they be? Well, I don't know, but it could be something like very old arcs and rifts that formed very early on in the Yilgarn Creton history. We then have the north-northwest structures. They often control the orientation of the greenstone basins. They get preferentially reactivated during crust shortening and form, all of those boundaries. Again, they're not always parallel and they're not always in that orientation, but as a rough approximation. And then interestingly, in the Paleoproterozoic, we have the margins fail, in the north and in the south, parallel to these east-northeast trends. So this is a situation where basically you get a failure of the entire crust and lithosphere, and you kind of get parallel to those primeval structures. So it's tempting to say they are sequential, so the east-northeast trends are older, but there's also possible that there is some sort of a long strike segmentation forming initially in these structures, in these old structures, that then get also activated. It's very difficult to pick apart, but you wouldn't be expecting long kind of linear belts to form probably. So it's quite likely that there may be some sort of length scale variation in those as well. So one thing we could do is, because we have seen that different data sets show different things, we could go and interpret this as a sort of a matrix. So you could look at what kind of data sets you have. And I've only just started in making some random ticks here in the boxes, right? People would disagree anyway, so I didn't take it very far. But we have the active seismic, the passive seismic, different types of data coming out of that moho structure, MT, gravity. These are all geophysical methods. Then we have more kind of geochemical or isotopic ones, what Rose considers interesting. So, so yeah, there's some falls that basically, or some structures that are very clearly shown in everyone, except maybe for the S-wave topography. But there's some that are not shown in some of those, and that has to do with, maybe gives us a hint as to the age of those structures or how they behave, and the overprinting that happens over time. So you can do that at liberty, ad nauseum. You can add gold cams, nickel, lithium, whatever, and you can test what data sets gives you what. So there's something we could possibly do in the future. But yeah, it's quite clear that some data sets don't have time components. Of course, some of them are only measured today. So that's one way of attacking that in the future. So why does this activation and reactivation matters. Well, yes, there's structural control on mineralization. That's quite clear. There's a sort of you could think of a sort of a segmentation between like gold prospectivity as well. We have the kind of the northeast Yilgarn, the Leverton area is kind of offset. People have pointed it out many times before relative to the Kalgoorlie area. We have a domain here that's again possibly a bit different to the rest. And of course, this also matters. The reactivation also matters for understanding the overall structure of the margin itself, and also of the basins, as Charmaine has pointed out. So we start, in the Permian to rift, preferably the Southern Carnarvon Basin, and maybe some small parts of the Perth Basin in the south. Really great work by GA and Lisa Hall, like about 9 years ago. This is a combined gravity image published by Ron Hackney from GA, showing the scale of the structure. So we look at the Yilgarn, this massive thing, but if you look at the overall scale of the margin, this is really not very big. One thing also to point out, is really important in the Permian. There's a part of the Permian of the Perth Basin that sits on the Yilgarn, not on the Pinjarra, and that's the Collie Subbasin. So we form parts of the basin in this orientation, right, in the Permian, and then later we break up, and so the breakup, of course, has to be somehow controlled by the structure of the craton and the craton margin, and so we can reasonably well understand. I think this has been shown by the talks before as well, what the Mesozoic looks like along the margin, and we have a kind of reasonable understanding what happens in the Archean, but the real missing link in this is what happens in the Proterozoic, right? So there's a lot of structures that come in and shape the margin of Proterozoic that we have very little handle on today in our understanding, and so very typical. Even though this is the rifting, this is the mid-ocean ridge. At the time, the initial opening is oblique, very typical. Hardly any margin opens up at right angles, so that's really an important thing to consider. So all of this generations of reactivations of different types of orientations in the craton have an ongoing effect. That's really where I want to leave it, and I think it's quite clear that this is not the end of anything today. It's a milestone in our journey, and we're quite happy. We're so grateful to be able to share it with you and get your feedback for it. Before we progress, there's a number of thanks that I'd like to talk to. Dave Martin and David Howard, they were put a lot of work in the planning and the contracting of the work of the acquisition of the Southwest Seismic Line. Many people have liaised with HiSeis, now Fleet, doing the processing, but it was mainly Raphael and Charmaine who did that. So thanks to that. Andy, thanks to them. Andy Calvert and Max over here made a great contribution, a lot of technical input regarding the processing. Reese Connaught at HiSeis was a great partner to talk to. Anik, Francois, Michael Prowse, and Adam Simons, and Beck and Meg Stewart did a lot of work the last few days to get everything together for the event today. And of course, the interpretation team. So it's basically GSWA, the people that are here today, plus a few more, plus Mike Doublier, Brian Kennett as well, who helped us with understanding the Moho better, Andy Calvert. And so we've run fortnightly meetings over the last year and a half, and a lot of head scratching and intellectual gymnastics to try and understand what we look at in those wiggles on the map, on the profiles. So yeah, thanks for sharing the day with us.